When you look at some young galaxies like this one, you expect them to be pretty simple, mostly hydrogen and helium. Maybe some oxygen from early supernova explosions, but nitrogen, that's a tricky one. You see, nitrogen takes time to produce. It comes from medium-sized stars that live for billions of years, slowly cooking it up in their cores before releasing it late in life. Hey there, I want to tell you about something wild that the James Webb Space Telescope just found. A galaxy that might contain stars so massive they shouldn't even exist. Meet GS 3073. The galaxy is sitting about 1 billion years after the Big Bang, and it's honestly breaking all our rules about how the universe works. So imagine our surprise when we pointed our instruments at GS 3073 and found nitrogen level 20 times higher than what's in our Sun. In a galaxy that's barely had time to form its first generation of stars. It's like finding a gourmet meal in a kitchen that just opened 5 minutes ago. But wait, it gets stranger. This nitrogen isn't spread throughout the galaxy. It's concentrated in a tiny super dense region right near the center, maybe just a few hundred light years across. And here's the kicker. The carbon and oxygen levels there are totally normal. It's only the nitrogen that's off the charts. This tells us something dramatic happened in that small region, something that produced massive amounts of nitrogen without creating tons of carbon or oxygen alongside it. Right now, the best explanation we have is almost too incredible to believe. Supermassive stars. I'm not talking about big stars here. I'm talking about monsters weighing thousands, even tens of thousands of times more than our Sun. This would be the largest stars in the entire universe. You see, in the early universe, stars could grow to these absurd sizes because they formed from pure hydrogen and helium, without heavier elements acting as a brake on their growth. They could become the true titans, and their turbulent massive cores would be perfect nitrogen factories, converting carbon directly into nitrogen and blasting it out into the space through powerful stellar winds. The math actually checks it out. When researchers ran the models, the chemical signatures from these hypothetical supermassive stars matches exactly what we're seeing in GS 3073. If we're right about this, it solves another huge mystery that's been bugging astronomers. Why do we keep finding supermassive black holes so early in the universe? If supermassive stars existed, they would collapse into black holes weighing hundreds of thousands, even millions of solar masses right from the start. No waiting billions of years for them to grow. There'd be cosmic, fast-track seeds for the monster black holes we see everywhere. In fact, GS 3073 already has a black hole that's way too massive for its size. Maybe that black hole started as one of the supermassive stars just a few million years earlier. Look, I'll be honest with you, this is still a hypothesis. We need more observations, more galaxies showing similar signatures, but two independent teams have now confirmed this bizarre level of nitrogen, and that's making it really hard to ignore. What excites me the most is that GS 3073 might be showing us a fossil record, a chemical fingerprint left behind by the universe's most extreme stars, stars we have only imagined until now. The early universe was a wilder place than we thought, and I have a feeling we're just getting started with discoveries like this. Stay curious out there.